Yeah, so 10 minutes, I have to go quickly for my result. Actually, this is not the final one. The, the, the file is not the final one. Okay, so this is not final one. The final one, actually, I added the picture from the moon, but it's okay. So we'll go for this one. So yeah, so yeah, it was launched August 5th, so almost 11 months, and then we were able to go through like the deep space almost 5 months, and now successfully we are collecting data from the moon, and it was for 1 year mission, but now 2 years is extended. Oh, yeah. So the instrument, we have 6 instruments, including NASA's the payload, and I'll talk about only gamma ray spectrometer. I don't know what this one. Okay, okay. Yeah, KGRS. The main detector is lanthanum bromide, but the shielding detector is 5% boron loaded plastic. And every 10 seconds we get the data, but very, very light, 6.3 kilogram. And we actually can measure the X-ray regions like from 30 kV to 12 MeV. And fortunately, we actually can measure neutron as well as X-ray and gamma rays. And we are aimed to have at least about 10 elemental maps. And also this can be good for geology and lunar resources. So today, because we didn't do much of the elemental mapping, but I can talk about gamma ray bursts and then solar activities, how we measured. So as you can see, yeah, so this is the mission schedule. So we will measure up to, end of 2025 as an extended mission. So gamma ray burst was we detected, and the solar events are very important, and we actually did a good measurement. The mapping started just now. And I know everybody know about the strongest GRB ever recorded, and that is 1 in 10,000 years. So then NASA reported, and it's far away. It's 2.4 billion light years away, and that is originated from Sagittarius constellation, and it is really happened about 2 billion years, and then that actually measured by KGRS, and when the KGRS can far up to about 1.55 of a million kilometer away from the Earth, and it happened. We measured around like 1.51 million kilometer away from the moon. The Earth. And the gamma ray burst line, actually, we made channels, about 5 channels from the X-ray region to 3 MeV, kind of energy slot. And then total count for our detector, like a main detector is lanthanum bromide, and also the BLPS. That also we have the total count. So the total, we have about 8 channels we actually used as the monitoring gamma ray burst. So you can see that the image of the X-ray image for when the GRB 221009 happened. The previous one was just like a short the channel, but this one, this spectrum is a whole spectrum up to 7 MeV. So if you think about the lowest one is actually for the background spectrum in deep space, but when the top one is actually the first gamma ray arrival. So if you consider how that is stronger, then you can see that about 1,479 times the higher count we got. So this much actually the gamma ray burst this time was very strong. So this one actually proved, and the second one was much lower, about 100 times, about 200 times higher than the higher count we got from the background level. And if we consider this kind, our measurement with the Fermi data and the time and all the patterns are well matched well, so we prove that our KGRS, instrument itself was used good to measure good gamma ray burst measurement. I think we never had this kind of measurement using gamma ray spectrometer. Of course, gamma ray spectrometer was used for Mars, Mars exploration and some asteroid also, but this is first time we are actually measuring. And if we consider with other, the evidence that also well matched, and I will skip this one. And another important thing is the solar cycle 25 that is actually exceeding the prediction. So right now we are in the solar activity is going up from 2023, and because of our extended mission, actually we are able to see solar cycle 25 maximum and a little bit beyond. So the black box, region could be about 3 years of the measurement we can do for solar monitoring, solar activity monitoring. So consider to so I'm saying that we're gonna have a good monitoring activities we get from KGRS. This is very powerful situation that if we consider all previous measurement with the solar activities, actually 5 major measurement actually compare with the NASA solar activity record. So the one I'm showing is about March 13 to 15. So this one has like a coronal mass ejection. So this is very strong case and when we compare with the KGRS, and you can see that the right side, okay, so left side you have is the NOAA data. So NOAA data actually provide the proton. So the red one shows about the proton flux increase, the time of March 13, and then that is actually the energy is above the 10 MeV, and most solar the proton energies are below 100 MeV. And interestingly, if we compare with the KGRS data, and then the bottom part is actually neutron increase. So proton induced interaction to the surface actually gives a neutron increase. And then later on we see, interestingly, we see also the gamma ray and the X-ray regions. And all the activities are different, but this March 13 has this kind of signature. But this is quite interesting if we think about what is happening on the surface of the moon. So you can see the map with the solar event. I mean so left side. Okay, that shows that the top one is a neutron. So the dark red shows when the K payload move around, and at the time how the neutron count, the count was high. That's why the black, the red, and then the bottom one is actually the gamma ray, the total count from high gain. Yeah, so that kind of is important. So this is how we're gonna study. How we're gonna study for the surface radiation with this kind of solar activities, and then the lunar map. So I'll just show you what we have is slightly different than the Chang'e data, so because we have a low energy measurement. So this one really shows also the neutron signature of the thermal neutron capture. So this will have a very interesting result in the future, or we'll use for lunar mapping. And so the data, the top one is really showing the KPLO GRS is first map. It is preliminary for 3 months data, but that is showing thorium data compared with the other previous lunar mission. And then we're gonna do this kind of elemental mapping for lunar geology and the lunar resource assessment. This will continue for for the future for about 3 years. And we are convincing that we have a new result, detection gamma ray burst and then monitoring solar event. And then our lunar map is good for the radiation measurement as well as the elemental mapping. And this can be used for future case for utilization of lunar exploration, especially human exploration or lunar ISLU prospecting. Thank you.